Here we go, we're recording now. Okay, I want to talk about what we've got going on for the next couple of weeks. So as of right now, I have loaded into D2L a comment about the exam next Thursday. So I want to talk first about exam number 1. I brought to class the practice problems and the solution sets, and I gave them out on Tuesday, right? Those are now loaded under week 6 in D2L. So just in case you're one of those students who is not attending, or you're constantly Zooming, or you're just watching the videos behind after everything else. Thank you, Demondre. If you're one of those students and you didn't get the paper handout here in class, it is loaded into week 6. This is week 6 in D2L. Hey, we're almost through with week 6. It's awesome. We're getting close to halfway if you don't count after Thanksgiving. So go ahead. The test is next Thursday. That's October the 8th. So go ahead and start looking at those sample problems and the solutions, and make sure you're okay with everything, because if you are having questions about them, then Tuesday coming up is your opportunity to ask me questions. So Tuesday, October 6th, bring questions. Now, I say it normally about the review questions because I'm giving those out and that's what you have available. However, if you have some weird question from the homework that you feel hasn't been answered, or something like that, then that will work. Hang on a second, I can't see your comments. Go away. Okay. Oh yeah, somebody else told me that too, Elijah. Thank you. That for whatever reason I had exam 1. And I think I meant to do it this week, and then we pushed it off a week or something. So I will change that in D2L so that it says exam 1 is due next week. Thank you for letting me know that. I know apparently I didn't know that it sends out things that say, hey, you have stuff coming up that's due. Mm-hmm. I didn't know that. 2
days you have an assignment that's due and you don't have anything turned in for that assignment.
It'll tell you, hey, you haven't done this yet. Oh, cool. Okay, so that's why y'all are all getting something say that exam 1 is due tomorrow. Sorry about that. I'll change it to next week, and then you won't be stressed out about it anymore. Thanks for letting me know. So I'll update that probably as soon as I get back to my office. But anyway, bring questions that you want to talk about for the exam. I will go over the format for the exam and the way my tests normally look, because sometimes my tests look weird compared to other straight math tests, because I consider this more of a math education class, because we're doing the geometry. We're talking about how we would do that with students and so forth. But yeah, so I'll talk about the format. I will talk to you about the things I think are like most important. Make sure you can do A, B, and C. But if you have questions off the review or questions that you want to ask me about, this is your opportunity. All we're doing on Tuesday is review. Okay, that's it. Next week is review and test. So be sure that you are ready for that and bring your stuff. I also put on D2L, and we can talk about it now too, that I need to know where you are testing so that I can have an exam there for you. So as of Tuesday, I had 9 people who said they wanted to come to Commerce to our classroom. I have Demondre, Summer, Ashley, Ryan, Christina, Alexis, Garrett, Jessica, and Elijah. Those 9, you guys said you want to come into the classroom, which is Binion 329. Okay. Binion 329 or Ferguson 308. That's what I need to know. So a couple of you have emailed me and told me, hey, I'm going to be in Ferguson, no problem. I will get you an exam over there. If you have not told me that, or if you have some kind of unusual circumstance that we need to schedule some other way, then let me know. But these are the two face-to-face options that we're doing. This is a face-to-face class that we signed up for, even though some of you aren't coming, I know. But so the expectation is tests will be face-to-face if at all possible. So those two are where we're planning to be. So yay. If you have not told me yet, today is October 1st, and I put on a due date on that of October 6th. So let me know where you're testing. And if somebody, you can email me or you can message me in the chat, whichever. It'll be all right. Okay. We'll work it all out. Okay. I also put in, so let me talk about things that are due, basically. I also put in the D2L that we were working last week and this week on the proofs. And so if you were attending and participating, then you should already have in D2L, already entered it 100 because you got the participation grade. One was for last Tuesday, which was this 4.7 guy. Okay, we actually did all of that between the 2 days. One is for Thursday, which was this 5.7 guy. We didn't do all of that. We did the DART one. I don't remember if we do it. I don't think we did any of the others. But so that was a participation for that. And then one was for this week. We worked on planning a geometric proof. The 13.2 guy, we did this one. I don't remember if we did another one, but that for sure we did that one. So if you weren't in Zoomville, and if you weren't in Commerce in class, then you need to go in to D2L, find the appropriate participation folder, and upload what we did in class. If you do more, that's fine. But at least the things that we did in class were these 3 handouts, right? Again, if you were here or you were on Zoomville those days, I've already got your participation grade loaded. You can go look under grades, and there's 3 participation grades. But if you were not, I'm just making sure you're keeping up with the videos and stuff. Tuesday, Thursday, and again Tuesday. That was September 29th. So go back. I think this is the 22nd and the 24th. This is week 5. This is week 6. Okay, so that'll give you enough to look at to see the videos. So if you weren't in here, if you currently do not have a grade on those 3 participation grades, then you need to do these 3 and get me some participation uploaded so I can tell you're keeping up with us. And that's also due October 6th, Tuesday. If you were with us, then congratulations. You've already got that and you're done. Yay. All right, that's just to make sure you're keeping up with what's going on in the class. So those are out there. What else? You've got, there's something else due on the 6th. Oh, proofs, yeah. The 12 proofs. It's like the 12 days of Christmas, but it's 12 proofs. So that project that we're working on, thank you. Also due October 6th. Okay. So basically, I want you to have everything off your plate by Tuesday, because between the day that we review on Tuesday in class and when you take your test on Thursday, all I want you to be doing is worrying about the exam. Okay. You'll have another GeoGebra project, right? Mm-hmm. It's out there. Yeah. It's due the next week, right? Basically.
Yeah, the 13th.
Okay, so you've got time on that one. But, you know, after you get done testing on the 8th, if you're like, man, I don't have any homework over the weekend, I want something to do, and you want to get ahead on that GeoGebra project, it's already loaded up in D2L. We've already given out handouts. You should be good to go. All right. I think that's it. All we got left. We're exam 1. Then we'll start working on circles and stuff. That'll be great fun. All right. Is everybody okay with that? No questions? See the list from the top? Yes, ma'am. All right. Yes, ma'am. Is that good? Can I remove it? Yep, thank you. Perfect. All right. So again, let me know if you're testing in Commerce or if you're testing in the ATC. Like in Commerce, when I say that, I mean in the classroom. Sorry. In the ATC. Yay. All right. Let's see, where were we? We were looking at proofs. Unless we saw our heroes. Where is my set of proofs? I've got it somewhere. Give me a second. There we go. Okay. Is there one on the 13.2 page that you want to work on? Or on the 5.7 page? So the 5.7 again was this quadrilateral stuff. The 13.2 again was the planning a geometric proof one. Is there something anybody wants to see from there? I haven't prepped them, but we can always work on stuff if you're like, oh my goodness, I don't know how to do blah.
I think we wanted to show like one of the Converse.
We are, yeah, for sure. So I keep on coming back to these because some of these are like just random proofs that I could throw on an exam pretty easily or something similar to them. So I want you to get a good feel for like on 13, on the flow charts, well, how those flow. Hopefully y'all are pretty good by now because we've done 3 or 4 days now with those, I think 3 days. But especially these planning a geometric proof ones, this is from scratch. And we've only done one of those. So if I threw something like that on an exam, I would want you to be able to do it, right? So. Number 6, okay. We can totally do that. Like I said, I haven't prepped it, but we can look at it and do it, and we'll be okay. All right, so request for number 6. Anything off flow charts, or y'all feel really good about flow charts? Okay.
Yeah, we did.
Okay, good. Good, good.
I'm pretty sure we did in class.
We did 3.7 in class, but we didn't finish 5.7 in class. So I hope that means that you feel confident or you've worked them all and all that and not, I haven't bothered to look at them because they're freaking me out and I haven't done anything, because putting it off will not help you. Okay, so we have to do some stuff to get there. All right, so Miss Ashley in Commerce has asked me for number 6 on 13.2. So that's where I'm headed. So please, 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 between now and Tuesday, work on proofs. You're not going away. We'll have a second batch of proofs with a second test. So you're just going to stick around for us. Is it possible to fix the blurriness? Oh, I'm sorry. Hang on. I didn't know it was blurry. Let's try again. Is that better, Miss Samantha? Let's see. Okay, on your end, good. I'm like, my TV in Commerce went out, so I can't see it, so let me turn that one on. It's like behind me, so I'm gonna turn that on and see if it helps me see how blurry it is. Sorry. Hopefully it's good. It's coming up soon, I hope. All right, 13.2, number 6. Oh, it went on again. What is your deal, man? I don't know. Oh, now it's on again. Must be something. Somebody must have pulled a cord going back there or something. Okay, y'all will just have to tell me if things look weird. Sorry. Okay, here's what it says. You have right angles A and P, and the measure of angle B equals the measure of angle Q. And they want to show that the measure, or I'm sorry, that angle DCB is equal to angle SRQ. So let me copy this picture over for us. D is way up here, C, B, A. And then this guy is basically, it looks to me like the reflection of that. So S is way up here, R, Q, and P. Okay. So the given says you have a right angle at A and P. Okay, and we know that if there's only, they only normally say that when there's only one angle that they're talking about. So they mean this guy, right? They mean the one that looks 90 degrees. They don't mean the outside, the exterior. So we pull A and P, those are right. Okay, and then it says angle B, measure of angle B, is equal to the measure of angle Q. So which guy do they mean there? Okay, this guy here, the little b here and the little q here, right? That's what I heard. Okay. So those are the givens, and then it says show this. Show that angle DCB is congruent to angle SRQ. Okay, so be careful about this because this is not one of the angles in the triangle, right? This is the outside guy. DCB is this obtuse angle on the exterior over here. Okay. And it's congruent to SRQ, which is this obtuse guy. That's what I'm supposed to be showing, right? Okay. So again, I want to, if we can, walk through the thought process first, and then we'll try to put all those statements and reasons together. Okay. So what do y'all think about that? Is it true?
Yeah.
Yeah? Why?
There's only one amount that you would do for the triangle. The last part of the last angle is inside the triangle. And do both of them, and then because that and the part we're trying to show are going to be equal to 180. Yeah, that gets us that.
Okay, so what I'm hearing here in Commerce is that this third angle inside of the triangle, we can show that those are congruent. Okay, and we'll have to show that they're congruent. But, and we know that because why?
Because the other two are congruent. So
Okay.
it has to, it's forced.
Okay, these two are congruent, so those two are congruent. And actually in this case, what we have going on is an angle, angle, angle situation, right? So because we have two angles given and those are congruent, the third one has to be because it is forced into it. And these are similar triangles because we have angle, angle, angle. Let me see what we got here. If we can prove that angle C and angle R are congruent, then the angles they are asking for are linear pairs to those. Yes, ma'am, absolutely. And that's what I'm hearing here, right? So once I show that these are congruent, then these guys, the big DCB and SRQ, those have to be congruent because they make a linear pair.
Could we like be able to skip the angle, angle, angle and go straight to the exterior angle conjectures?
We could. What does that guy say?
That an exterior angle is equal to the sum of the two opposites.
So if you really saw it, and so that gives us two different methods for proving this, right? And I don't care which one you use. Again, when you get on a test next week, whichever path you see, all right? So you walk through your path and you show me. Now, if you have the same proof as I do, that's awesome. But if you don't, it's fine because I'll just follow whatever your rabbit trail is and go down that hole with you, right? Sorry. So some are saying, look, we have that exterior angle conjecture that says the exterior angle to the third angle of a triangle is equal to, or congruent to, the measurement is equal, the angle is congruent, the sum of the other two. okay, the opposite two angles. And so she wants to say, hey, look, I could just use that exterior angle conjecture, which is absolutely true, and say DC is equal to A plus B, basically, measure. Measure of this guy is equal to the measure of these guys added together. So therefore, since these equal these, then we can do some kind of a transitive property and dump out the middle. And so the outside guys will be congruent. Absolutely. Do we want to see both of them or just one? You want to see hers? Okay.
That's where my brain went, because that's what they're automatically given.
It's shorter, right? It's a shorter process. We are given these two, so it's easier for us to come up with those have to be equal to each other. And then that one has to be because of the exterior angle conjecture, which is just one statement, basically. It's not necessarily better, so I don't want y'all to get discouraged, because you can easily show these two are congruent and then they're linear pairs. Absolutely. It's just going to take an extra step. Okay? So I like both, but Ashley said, let's do it Summer's way. So nobody's yelling, so we're going to do that. If you want to see it the other way, speak now, and I will do it after I do Summer's way. But absolutely, two different ways to get to the same thing. I love it. And hopefully, if we're using all of our properties correctly, they will both work out the same, right? It doesn't matter which way you go. As long as your reasoning is right and your math is right, we should be golden. All right. So, what would be my first statement? Oh. Angle P and angle A are right angles.
The measure of angle B
And the measure of angle B is equal to the measure angle Q. And she knows that because it's given. Okay, if you know nothing else about proofs on next Thursday, whenever you start your proofs, you should all know that the very first step that you do before you do any other reasons and statements is whatever is given. Just go ahead and knock it out there. And so you'll get the first step of your proof right, okay? You always start with the given. It's awesome. Okay, there's the first step. So what I'd like to do is, because they gave me this measure guy, I'd like to kind of work with measures. Does that make sense? We can do that easily here with this first step, angle P and angle A are right angles. I can get some measurement stuff. How do I do that? Like the measure of angle P
It's 90 degrees.
is 90 degrees. And the measure of angle A, 90 degrees. And how in the world do we know that?
Definition.
That's the definition of a right triangle. Or right angle, sorry, not triangle. Keep me straight here. Don't let me get off the wrong path there. Definition of the right angle. Okay, and again, that's one of those things that people are like, well, duh, but you have to put it in there, okay? You can't just say, well, of course it is because it's 90 degrees, it's right, or it's right, so that makes it 90 degrees. You have to state it. Give me all the statements.
I have a question.
Yes.
If you started off with just saying the measure of angle P and angle A equal 90, and you say that's given, can you do that, or you have to say exactly how they gave it?
You can't really do that. Sometimes I've seen people shortcut that, and we know that those are equivalent statements. So the fact that they gave me angle P is right, and the fact that measure of angle P is 90 degrees, they're equivalent statements because we know the definition, but they did not give this. Does that make sense?
Yeah.
So you can't say that was given. So you have to be a little careful about it. It's just one extra step, but it's kind of a pain because you have to remember to do it. Does that help, Alexis?
Yes.
Okay.
Well, at this point, can you say angle P plus angle Q equals angle A plus angle B?
How do you know that?
I don't know.
So she wants to say measure of angle A plus measure of angle B, which is exactly where I wanted to head for, right? Is equal to, or if you wanted to even, you could say 90 degrees. That's fine. You could substitute that out if we want to. She wants to say this is equal to the measure of angle P plus the measure of angle Q. So that's what we want to say. I don't know what that weird ding was. That's not a normal ding.
I think her noise was still on.
Oh, okay. Maybe okay. Background noise. That's what we're going with. Like, that's not a normal theme that I hear in here. Okay. So she wants to say that. How in the world is she getting there? We might need a step before that, but that's where she wants to head.
Can you like somehow say measure of angle DCB equals SR? Wait, I don't know. I was trying to say because of that, then the other two angles are equal.
Yes, I agree 100%. You want this. You want to get here.
Oh, I don't know how you get there. Like, what do you say?
So we're going to have to build off of these two statements. That's the problem. And this is the whole reason why, guys, we've been spending a week and a half working on proofs. Normally, if you haven't noticed, we don't spend this long working on any one little subject thing. But for proofs, there's a lot involved with them, right? And so I want you to process through that and get that process in your gut of, okay, what's next? How do I get there? So yeah, we want to get here because if we can get here, so we're going to skip a step here. We'll come back, okay? Let's finish out the end of the proof and then we'll get from here to here. So how would we know this? Angle A plus angle B. Oh, hang on, I'm seeing this.
Do you have to clarify that, like, you kind of stated it, but measure of angle P is congruent to measure of angle A? Do you have to write that statement?
Yes, ma'am, we need that in there so that we can show that they're going to be able to add up, right? Okay, to be the same. So can I stick that statement in here somewhere? Mary wants me to say that. I know, I should have left more room. So because these have the same measure, does everybody agree angle P and angle A have the same measure? Okay, so because of that, we can say angle P is congruent to angle A. And how do we know that? Oh, you know what? Here, I'll stick it here. We'll come back to this statement. Okay. I could say it in congruency, but I changed my mind. I'm sorry. I want to keep in measurements. Yeah, so I want to keep it in measurements and keep it equal just because we changed it to measurements. But we know they're congruent, and you could say congruent because of the definitions of congruency, right? But what can I do with this right here that'll get me to Mary telling me that P and A have the same measurement? We know it. It's obvious. They both equal 90 degrees. All right, but how can I shove that together somehow? We could do it one of two ways. We could either do the transitive property, which would be like measure of angle P equals 90 degrees equals measure of angle A, okay? And then we would dump out the 90 out of the middle of them, and that would use the transitive property. But I don't have to do that. The transitive actually gives me an extra step, and if I don't have to, I don't want to. I could do what? Right here, this guy equals 90 degrees. But I know that 90 degrees is equal to the measurement of angle A. Oh, I can just directly substitute in, right? Yeah, I could do that. So now I know the measurement of angle P equals the measurement of angle A, and that's just straight substitution. So we're going to come back to this statement. I'll rewrite it. So Mary says, okay, because they have the same measurement equal, we know they're equal to each other. Absolutely. Okay. Now what?
Can't you go back to the measure of angle A plus measure of angle B equals measure of angle P to measure of angle Q through the corresponding parts of congruent triangles?
Yeah, we don't have triangle congruency yet, but there is something that allows me to add two angles together. Somebody look in your word bank, and it's something about adding angles.
Triangle sum.
Hmm?
Triangle sum.
No, it'll actually say angles. It might be on your postulates list. I think it's somewhere on that word bank, but I think I'm thinking from your postulates list.
Corresponding angles postulate.
You only get corresponding when you got
Angle
congruency.
addition postulate?
Angle addition, that's what we're wanting to do here, right? So what we're saying here is if A and P have the same measurement and B and Q have the same measurement, then we know that adding A and B has to be the same as adding P and Q. And we can add those together because of the angle addition property. That's what I was looking for earlier. So it's the same statement we wanted to use. That's where I think it was Alexis was taking us, right? She wanted us to do that. We need this equal statement first so that we can indeed substitute them out. But then we have angle, yes ma'am.
No, if you already did them given yeah, never mind.
Did we miss something? You got the B and the Q. That's okay. B and Q, we have those equal.
I'm scared that we're gonna have to put in another step for
A and P, we have those equal. And then we add angles. So I'm like, you really want to add your angle. It's angle addition, right? That's what we're doing. So we have congruent or equal pieces adding to equal pieces. So we're okay, I think. You could literally say it's like, so think of it this way. Maybe this will clarify a little bit. It's like we have this guy right here, the statement that these two are equal, and we're wanting to add onto both sides of those something. If you wanted to do this, you could add an extra piece in there. Yeah, exactly. So we don't want to do it, right? But if you wanted to, you could do that, and that would be the addition property for equality. So I can, of course, add anything to there as long as it's equivalent that I'm adding, right? Equal statements. So on the one side, I would add the B, and on the other side, I would add the Q. And so that would get us to this statement if you wanted to do something there. But yeah, and that would just use addition property of equalities. So if you feel like, oh, I'm still not quite getting it, you could do that. It would be okay. But that's what's happening. Because we know in an equation, I can add anything to both sides of the equation as long as they're equal. All right, there we go. Okay, so we have these two equal, and we're trying to use Summers' idea that tells me that I have these guys and an exterior angle, these guys and an exterior angle. I need to bring those in, but before I do that, I can't just jump straight to the angle, exterior angle, because why? I need to define something. I need one more little statement in there. Trying to get to DCB and SRQ. But nothing in our proof talks about DCB and SRQ. So we need a little statement about them. Yes, good. So we need a statement in there that tells us angle DCB is exterior to angle C and angle SRQ is exterior to angle R, right? And again, here's my picture. How do I know that those are exterior to those guys? It's another one of those kind of duh moments, right?
It's outside the triangle.
It's outside the triangle, right? So that makes it an exterior angle. So I need what? A definition? Yeah. Anytime it seems like, well, not anytime, but most of the time when it seems like, well, duh, you know, of course, you're saying the obvious, then your reason is almost always going to be some kind of little definition. Okay. Yeah. And so that trips people up, but it's actually the easy part. Don't let a definition trip you up, right? You're like, well, I know that, but I don't know where it's coming from. It's almost always a definition. Okay. So now what? Last step. Whew. Oh, Alex.
No, wouldn't that be the last step? The one marked out.
I already put that there. I need something before I can just flat out say these are congruent.
Would we have to say that like angle DCB is equal to angle A plus angle B?
Yep. Measure of DCB is equal to the measure of A plus the measure of angle B. And how do we know that?
Exterior.
Exterior angle
Conjecture.
conjecture. Okay. That's the whole point that we were after, right? That's what Summer wanted to use, so that's why we're doing it. If you went the other way on your proof, it's fine. You don't have to use this. It would be all right. Okay, so we know angle, measure of angle DCB is equal to measure of angle A plus the measure of angle B. We want it to pull in this step that Alexis had earlier, right? So that we can use that statement. That's where we're headed. That's what Ashley said, right? We want to pull this in. So we've got it right there. Measure of angle A plus measure of angle B. Okay. And we know that measure of angle, the other one is SRQ is equal to what? Okay. Measure of angle what? P plus measure of angle Q. Again, we're just pulling in this guy. We want it to look the same. Okay, because we've got something about that, so we pull it down here. Because in a second, we're going to use this, right? And that's how we're going to conclude everything. So that's the same reason, exterior angle conjecture. Okay, I like it. And so now we're there. We know that this equals this, right?
Mm-hmm.
The substitution again?
Oh yeah, we can totally substitute here.
And then we have to switch it back to.
Or, technically, I don't think I can substitute here.
Sorry.
I need to transitive it. Yeah, I'm sorry. But yes, you're right. So measure of angle DCB, because only because there's so many of them. If this was the exact same thing, then yes, I could substitute. Like earlier, they were both equal to exactly 90 degrees. I can substitute. But this isn't the exact, they're equivalent. Measure of angle DCB is equal to measure of angle A plus B is equal to measure of angle P plus measure of angle Q. I'm not going to have space. Which is equal to the measure of angle SRQ. All right. That's transitive stuff, right? Because I got a big long row of stuff. I've set them all equal. And what we'd like to do is what? Drop out the middle guys, right? Because we know that these are equal. We can dump them. Measure of angle DCB equals measure of angle SRQ. That's still the transitive property. We're just getting rid of the guy in the middle. All right. And then Ashley said it's not enough yet. We're so close. We're there. We have the measure is equal. We need what? congruency. Now we need to restate what they asked us to show. Exactly, Maria. So we can't just stop right there with that measurement equals, right? We need angle DCB is congruent to angle SRQ. We need to make sure we're actually showing exactly what they want me to show. And I heard that's because of the definition of congruent. When you have two things measure that equals each other, you know that they're congruent by definition. Now we've stated what they asked me to show, right? So now we're there, yay. And then what?
Therefore.
Yeah, I'm done. Put your little therefore statement. Using the given, I'm not going to rewrite all that. Using the given, we see angle DCB is congruent to angle SRQ. I just don't want to rewrite all the given stuff, so I'm going to say using the given. What? We know they're congruent, dang it. We knew it from the beginning, right? But now we have step by step by step logical reasoning for why. Awesome. Okay. Boy, that was a whole page to do that one proof, Ashley. Yeah. She's keeping me busy over here. I love it. It's awesome.
When I read it, I thought we were going to have to prove that A and P are right angles. That's why I asked for it.
Oh, no, that was given.
Yeah, but yeah, that was
Yeah.
given. And I just can't read.
Dang it. There is one on your
The right angles are congruent.
proofs, yeah. There, and I don't want to do that one. I want you to do that one by yourself, but I can walk you a little bit through it. It's number 10. Right angles are congruent. All right angles are congruent. Okay. So the idea of that one goes along the lines of, and there's another one in there too, I think. Number 8. If two angles are both congruent and they're supplementary, then each is a right angle. So those two kind of go together. All right. So I don't want to walk through those. I want you to do those two by yourself because, you know, fun stuff. But the idea goes like this. My idea behind the proof goes like this. Let's look at number 8, for instance. If I have two angles that are congruent and they're supplementary, then what you mean by that is they make a right angle, they make a straight line, add up to 180 degrees. That makes them supplementary, which makes them a straight line. They don't have to be a linear pair, but I can use the linear pair idea, right? Because that's how I know supplementary, okay? And what we're saying is that we have two angles and they're congruent. Well, if I cut it like this, that would be maybe 30 degrees, and this would be maybe 150 degrees, right? Or something like that. So think about it like this. Okay, to make them be supplementary where they add up to 180 degrees, it's got to be 90. We've got to be cutting it in half. We're bisecting that whole 180 degree angle. But you can kind of use a little bit of your geometry. You can kind of say, let this be angle X and this be angle Y. Okay, I'm sorry, your algebra. And then we know X plus Y equals 180 degrees. Okay, but they're congruent because it was given. So can I substitute out, and instead of Y, can I call it another X? Because they're equal to each other. So now I've got basically 2 X's equals 180. And then because I've got basically 2 X's equals 180, I can use my multiplication properties for equality, because I know if I multiply by the same thing on both sides of an equation, I'm good, right? So I would multiply by a half, or you could think divide by 2. So if I did that, X equals what? 90 degrees. That's kind of what happens in Webster brain whenever I'm looking at those and I'm saying, oh, they're congruent. Congruent and they add up to 180 degrees. I kind of think, oh, well, if they're congruent, then that's the same thing. I've got 2 X's and they add up to 180 degrees. Oh, my X has to be 90 degrees. So you can kind of work through that proof if you think like that. That's number 8. And then number 10 is similar to that. So it says all right angles are congruent. That one's actually pretty easy whenever you get into it. What do we know about right angles?
Measurements.
Mhm.
Degrees.
So for instance, we could just draw 2 right angles. I'm going to call them angle 1 and angle 2. Just for ease of my, okay. So the problem with number 10, I think, is the statement. It's just all right angles are congruent. And people are like, well, where's my given? Where's my show? Because there's not an if-then statement, right? But we can make it into an if-then statement. So for instance, I would say something like this. Let angle 1 and angle 2 be right angles. Okay, it's a statement, okay? And then I would say, if angle 1 and angle 2 are right angles, I'm going to develop my own if-then statement, in other words, because they didn't give me one. Then what?
They are congruent.
Angle 1 is congruent to angle 2. Okay, so the actual proof for that's not long. You would need to talk about the measurement of each of them, and then you'd end up setting probably a transitive thing. Measurement angle 1 equal to measurement is equal to 90 degrees is equal to measure of angle 2. And then you dump out the 90 degrees, so measure of angle 1 equals measure of angle 2. And then you go back to the definition of congruency. So it's probably about just a 4-step proof whenever you get it down. But I think that the problem in that one is normally in, it just says all right angles are congruent. And so it's hard to know where's the if, where's the then. So in that case, I would say there's my given, there's my show. And I think y'all can probably do that with just a little bit of, that's the way I would probably approach that one. So I think y'all can do 8 and 10. It'll be good practice, especially since I've kind of pushed you a little bit in that way. Some of you have probably already done it and you're great. But that's the way I would go on those 2. Are we okay? All right, so let's hit one of these converses. We got about 20 minutes and I want to get a converse in before we head out for the weekend. So I'm looking at like number 3 or number 5. I guess it's 3, 5, and 7 from your proofs page. I don't want to do 7 because it's the interior supplements. It's going to be an adding together to make 180. Y'all can do that one, I think. Oh, Samantha said 7. Oh no, I don't want to do 7. I want y'all to have that fun, Samantha. It'll be a similar process to what we do for either 3 or 5, though. No, never mind. She says, okay, no problem. So, 5? Okay. So Ashley has chosen 5. She's the first one I heard yell, other than Samantha. Sorry, Samantha. I was saying not 7 at the same time she was saying 7. All right, here we go. Converse of the alternate exterior angles theorem. So this is the converse idea. So in a converse, remember what we're doing in this particular case is we're going to start out with some angle comment and we're going to find out that the lines are parallel. Okay, what's happening here because we're doing parallel line proofs. Okay, so this one says if 2 lines are cut by a transversal and that forms congruent alternate exterior angles. If 2 lines are cut by a transversal and that forming, it says, congruent alternate exterior angles, then the lines are parallel. Okay. So actually, actually, the picture for this one ends up looking just like what we're used to. It's two lines. We don't know that they're parallel yet, so we won't mark them with the little chevron, but they're looking parallel and they've got a transversal going through them. Okay, so the picture should look very, very familiar. We just don't have the little chevron yet because we didn't know that they're parallel. Okay, I'm going to go ahead and label my angles just like we always do. 1, 2, 3, 4. It makes naming things so much easier. 5, 6, 7, 8. And so y'all tell me, the given says the two lines are cut by transversal and that forms congruent angles. Okay, Maria says angle 1 and angle 8 are congruent. That's given. Is everybody okay with that? So I can mark that on my picture, right? Because that's what they're telling me is the given. Okay, good, good. And what I want to show is the two lines are parallel. Okay, so let's see if we can get this. Given. Get those statements. Can I call these one L and M and P? It just makes life easier to name this guy than a whole bunch of points. Okay, so what we've got is lines L and M are cut by transversal B, P, and angle 1 is congruent to angle 8. Okay, does that give me everything that's given? And the show is, we want to show L is parallel to M. Does everybody agree? All right, I like it. Good, good. Okay, so remember what we said last week about, or actually it was Tuesday, about parallel lines. There is a list of postulates. I gave it to you like week 2 or so. And those postulates are assumptions that we just assume are true, right? And we said whenever we're working with parallel lines, the one that is the assumption that they give me is which one? It's not alternate exterior. It's not alternate interior.
Corresponding or vertical?
Mm-hmm. Well, vertical is always no matter what because it's just any two lines that are intersecting, but the corresponding guys. So what it says is if you have parallel lines, then the corresponding angles are congruent, right? And that's a postulate. We just take it and run, okay? So what that tells me is, looking at it backwards, if I have congruent corresponding angles, then the lines are parallel, okay? Because it works. It's a postulate. You just take it, okay, and work with it from there, okay? So what we want to show is what? We want to get to, we know 1 and 8 are congruent. We want to get to some pair of corresponding angles are congruent. If we can get to corresponding angles being congruent, if we can show that, then we automatically have parallel lines. Is that okay? Mm-hmm. Okay, but I got to get to some corresponding angles are congruent. I would pick either the guy that is corresponding with 1, which would be 5, or the guy that's corresponding with 8, which would be 4. I don't care which one we do. 5, I hear. Okay. So Ms. Summer wants me to show, okay, can you show me that 1 and 5 are congruent? So this is our thought process. If we can get to angle 1 is congruent to angle 5, then we'll have corresponding angles are congruent, and then we have parallel lines. Y'all see our idea for the proof? I really think on these, it helps a little bit if you kind of think about it for a second and project what your plan's gonna be. And if you don't get all the way through it, it's okay. Like if you're like, I'm stumped here, just get a start on it. And that at least tells you a few steps of your proof so you can get there. Okay, so I need to get to angle 1 is congruent to angle 5. Okay, again, you could have done an 8 and 4 and I don't care. So again, lots of ways to prove this guy. Can we get to angle 1 is congruent to angle 5?
Vertical angles.
Okay, I'm gonna pass this up a little bit. So I heard what we're gonna have to do is angle 8 is congruent to angle 5 because of vertical angles. Okay, and then we'll get 1 to 8 to 5, and that'll be some kind of transitive something. Okay, and then we'll get our corresponding angles. Is this okay with everybody? That's our idea for our proof. We gotta flesh it out, but just to get started, basically. All right. Statements and reasons. I'm gonna stick my reasons way over here. I've kind of written in my space. I'll drop down a little bit. What's my first statement? Given heard. Lines L and M are cut by a transversal P. Angle 1 is congruent to angle 8. All that's good. Okay, let me make a clarification. I just want to make one quick clarification before we go on. So Alexis asked a minute ago about, we were given that, say, it was angle A was right angle, right? And she wanted to know, can she kind of just say angle A is equals 90 degrees as a part of the given? And I told her no. However, at this point, I'm kind of making up my own little thing there, right? So I didn't necessarily go with what they told me. So I want to make sure that everybody understands what I'm doing here. All I've done, here was what they said. If two lines are cut by a transversal and that forms congruent alternate exterior angles, I have not changed any values in there except to name things. Does that make sense? So you can change the given slightly if all you're doing is putting in names, okay? Just the picture clarifies what the statement says, okay? But I'm not putting in, like, substituting out values, okay? So I can put a name on it, that's okay. And in fact, that always helps you go faster, if that makes sense, I think, in your proofs, because now I can just say angle 1 instead of, like, if I had this as points, A, B, C, D, E. You know this takes forever, right? If I had all those points on there, then I'd have to talk about angle ABC is congruent to angle HEG. And even then, I'm still naming it, right? They didn't have a name up here. They didn't talk about angle ABC. So if it has to do with clarification from the picture and fleshing out so that we can have an actual example, you can do that in your given. That's okay. But you just can't substitute out values. I hope that makes sense. Okay, so these are my given. Okay, then what? Angle 1 is congruent to angle 8.
We jump to 5 and 8 because of vertical angles.
Yeah, and vertical angles happens all the time. It doesn't matter whether those are, angle 8 is congruent to angle 5, I heard. It doesn't matter whether they're parallel lines or not, right? If you have two intersecting lines, then the opposite angles right here, those are vertical no matter what. Vertical angles. You can even say that's a definition of vertical angles, but there is a vertical angle theorem, whichever way you want to go there. Okay, 8 to 5, we got vertical angles, and then we said our next step we were going to do was figure out how we could go 1 to 5 through the transitive property. What's that look like?
You have to say that angle 5 to corresponding first.
No, we're going to get the corresponding. That's actually almost my last step. Does that make sense? Yeah. So in this case, I can't assume that the corresponding are congruent because I don't know that they're parallel lines. So I've got to work at it backwards. So I'm going from, all I know is 1 to 8. I'm going to get to 1 to 5. 1 is congruent to 5. And then that's going to force us into corresponding angles, and then we'll have parallel. Yep, yep. So I want to use this right here I'm trying to get to 1 is congruent to 5. 1 to 5. 1 to 8. 8 to 5. Can I line that up together?
You do the transitive
I
property.
can. Yeah. Angle 1 is congruent to angle 8. Angle 8 is congruent to angle 5. Right? Just like that. Make that long string of stuff come out. And then we know from that angle 1 is going to be congruent to angle 5. And Miss Alexa says that is the transitive property. We have things that are congruent to each other. Just do that. Okay. Why did we care about those?
We have the corresponding angle.
Okay. So I would just say angle 1 congruent to angle 5 gives congruent corresponding angles. That's just the definition of corresponding angle. Is that okay? In fact, I don't even need that little congruent part. I could just say angle 1 and angle 5 are, sorry, angle 1 and angle 5 are corresponding angles. So now we know, yeah, I probably need that extra step. Angle 5. Congruent corresponding angles. That's just definition. And so now we want to say the lines are parallel. How can I do that? There's some postulate. So L, line L, parallel to line M. What was that postulate? It's always the reason, I think, that we struggle with just a little bit. We have congruent corresponding angles, which gives me L and M. That postulate's called the,
Corresponding angles.
there we go. Get used to you looking this stuff up, guys. Corresponding angles postulate.
What
Yes,
does
ma'am?
it say underneath transitive property? Definition of
Corresponding angles. Yeah, I just went back and put a name on angle 1 and angle 5 are corresponding angles, just so that we make it very, very clear. Let me put my picture here. Just so we can make it very, very clear here. Look, we got 1 to 8 because those are exterior. We got 8 to 5 because those are vertical. We had 1 to 8 to 5, so now we have 1 to 5. So I just put, I probably didn't have to put it there, but I just put one extra little statement there that says, look, so now we know angle 1 and angle 5 are corresponding angles. That's a definition of corresponding angles. And we know that they're congruent, okay? We just had that sitting around. So I actually probably needed this step, but I probably don't need that step. It's just an extra one, just to like pound it home. Okay, we have congruent angles, we have corresponding angles, and now they are congruent corresponding angles. I'm just trying to really like pound that in. You probably didn't have to do this step. I just threw it in there just to make sure everybody's agree. So corresponding congruent angles, because they're corresponding and they're congruent, that forces these two lines to be parallel. So now I can put the little chevron on there. A lot of times whenever you're stuck, go back to your picture. I think it'll kind of help us out. If you've gone through and kind of done the steps a little bit here. Okay, I'm going to go 8 to 5. vertical, 1 to 5, transitive, then you can help that to flesh out your proof a little bit. I think that helps. That's okay. You can't read my handwriting. I'm just like, that's the definition of the corresponding angles. That's what they are. Okay, so this was what I was asking to show. It says, then the lines are parallel. And I had under my show, L is parallel to M, so we're good. So I have indeed restated my show here, so I'm okay, good. So if I restated my show and I've got all my reasons in there, done. Okay, we need a therefore statement. What do you think? We don't have to exactly restate it. We can consolidate it a little bit. Therefore, if we have what?
2 lines cut by transversal.
I'm gonna skip that part. 2 lines cut by transversal and the
Exterior.
alternate exterior angles are congruent. So if we have alternate exterior angles congruent to one another, then what?
Lines are parallel.
Lines are parallel. And I'm kind of skipping a little bit just because I don't want to restate all of that. We know when we're talking about alternate exterior angles that we automatically had 2 lines and they were cut by a transversal, so I'm just kind of skipping that statement. It's not wrong if you restate it, I'm just being lazy. You know, that's why we have variables in math, right? Because mathematicians are, we have to abbreviate things. It's true. I just don't want to write all that. But yeah, just give me a little therefore statement. You'll be golden. Okay, so I think that, let's see. I'll leave that there so you can see it. I think on your special angles proofs for Tuesday, we've done 1, we've done 2, we've done 5, we've talked about 8 and 10. Yeah, I think we've done at least 5 of your 12, so that's almost half. So that's pretty good. Play with them and see. 2 on Tuesday. We're getting somewhere. All right, so everybody make sure you know this guy, special angles on parallel lines proofs, due on Tuesday. Do not wait till Monday night and be like, oh my goodness, I have to do all these proofs and I haven't looked at them at all. You still have 5 days. We've looked at or talked about at least 5 of them, so that only leaves you 7. Work from scratch. So a little bit more than 1 a day if you still haven't done anything. Okay, Miss Maria, can you hang out for just a second? I'm sorry. I haven't looked at that email. Okay, any questions? Let me call roll real fast before anybody jumps off the Zoom. All right, whenever I call your name, I'm gonna quit recording. If I call your name, then you're done. Have a lovely weekend. If you are watching the video, then have a great weekend. Thanks.